Ladies and gentlemen, welcome to Inter-Islamic Network on Oceanography event on the data processing tools for marine science. I am Bülent Çavaş from Inter-Islamic Network on Oceanography. I am working as a secretary. I will moderate this event today. Before starting, I would like to give you some information about Inter-Islamic Network on Oceanography. Shortly, INOC is interstate non-political and non-profit agency. It is an independent, autonomous, and self-governing institution under the umbrella of Organization of Islamic Cooperation Standing Committee for Science and Technology Cooperation. We, as INOC, is mainly collaborate and cooperate in marine research with to help each other in building capacity in the field of marine science. We are providing, exchanging information and maintain dialogue in the developments of marine science for mutual benefit and use. We initiate joint projects of marine research and development to member countries of the network. And finally, we help and assist in training of quality manpower for the member countries of network. Today, we also provide an excellence training webinar. The webinar will be given by Dr. Hakan Alyürük from Dokuz Eylül University Institute of Marine Science and Technology. We believe that this kind of training events will help researchers from network countries to develop further research project proposal for mutual benefit and use. Before giving the floor to Dr. Hakan Alyürük, I would like to kindly introduce him to you. Dr. Alyürük graduated from the Department of Chemistry, Faculty of Art and Science, Dokuz Eylül University in 2010. He received master degree in 2012 from the chemistry program at Graduate School of Natural and Applied Sciences, Dokuz Eylül University. His master thesis was related to investigation, field testing, and ecotoxicological testing of anti-fouling and eco-friendly biocides. He received PhD from Marine Chemistry program at Graduate School of Natural and Applied Sciences, Dokuz Eylül University. In his doctoral studies, he focused on marine biogeochemistry subjects, seasonal cyclings of nutrients, carbohydrates, and amino acids at Oceanographic and oligotrophic parts of semi-enclosed by İzmir Bay. Currently, he works on molecular characterization of organic matter in the marine environment. He also works on liquid chromatography. In his work, he uses Phyton and Matlab programming languages and software for statistical analysis, graphing, modeling, and data transfer from analysis instruments. Dr. Alyürük, I am looking forward to listening your presentation. Floor is yours.
Dear Dr. Çavaş, I want to thank you for inviting me. My name is Hakan Alyürük. I'm from Dokuz Eylül University. I'm a research assistant at Marine Chemistry Department in the Institute of Marine Sciences and Technology. Today, I'm going to present our Phyton and Matlab for oceanographic data processing. My presentation covers introduction to programming languages of R, Phyton, and Matlab, their installation and installation of add-on packages for them, and sample packages for ocean science data analysis. I worked on my PhD for biogeochemistry of İzmir Bay. During my PhD thesis, I worked with R and Phyton to analyze a lot of data. I worked on plotting statistical analysis of oceanographic data. After my PhD, I write a book that what I've done in my PhD. Its name is R and Python for Oceanographers, a practical guide with applications. You can find it from Elsevier. Now, I want to start with introduction to R. R is a programming language and environment for statistical computing and graphics. It's a project of GNU. It's a free software, which means scientists and students at universities can use R without a license cost. Data analysts also can view and contribute to the source code of R packages. In the meantime, this means you can write your own package in R ecosystem. The base distribution of R is maintained by the R development team. You can reach to its website from r-project.org. The R statistical environment is composed of two main parts: the base distribution system and add-on packages. Base system includes core functions to required R language. Core statistical functions and graphical tools are included as dependencies for other add-on packages. There are many statistical functions, such as statistical tests, linear models, non-linear models, data handling functions, and so on. Add-on packages are developed and maintained by the user community. These packages contain many advanced statistical and computational and graphical functions. The latest versions of R software for Windows, Linux, or Mac systems could be downloaded and installed from cron.r-project.org. Add-on packages can be installed from R console application under using R graphical user environment. You can select the desired package to install from the drop-down list of add-on packages. You can install add-on packages from the internet into package library folder under R installation directory or any user-defined library folder as below. This is the second method, alternative to graphical user interface method. There are integrated development environments to handle R scripts more easily. Some of these integrated development environments are official R console and editor, R Studio Desktop, Thin R, R Analytic Flow, and Visual Studio Code. The base software installation comes with an editor for writing of commands and scripts and an R console for execution of commands. There are also R Studio Desktop and Server, both available in free and fee-based editions, commercial editions. Customizable workbench with all of the tools required to work with R is in one place for R Studio Desktop. Now I want to introduce you oceanography packages in R. OceanData, OceanMap, Marelac, GSV, GSW, C-Carp, and others. There are many oceanography packages. For example, the OSHA package makes it easy to read, summarize, and plot data from a variety of oceanographic instruments. It also provides functions for working with basic seawater properties, such as profile, CTD profiling, and mapping, and temperature salinity diagrams. Also, you can plot section plots. You can view sea level data. You can view echo sounder plot. Also, acoustic Doppler data can be plotted. It is also possible to plot maps and satellite images. It provides functions for Argo float datasets. GG Ocean Maps is a package for R that allows plotting data on bathymetric maps using ggplot2 backend. Ocean Explorer enables easy access and exploration of the World Ocean Atlas of the US agency NOAA. It includes functions to extract data from the repositories and code to visualize several physical and chemical parameters. Ocean Waves package has summary statistics and process data from bottom-mounted pressure sensor data loggers. It is primarily designed to estimate several summary statistics for wave height and periods from a time series of sea surface elevation data. Other oceanography packages for R, Ocean Weave for weaving and transforming two-dimensional and three-dimensional data, Ocean Map for plotting two-dimensional oceanographic data. Maralac package provides datasets, constants, conversion factors, and utilities for marine, riverine, estuarine, and lacustrine science. Angstrom, Argo floats, NOAA oceans, and Satin packages. CCARP, GSW packages provides functions for seawater calculations. And R Marine heat waves, Copernicus Marine, and Pangear function, there are also these packages. There are also GIS, Geographical Information System related packages in R. These packages provide mapping solutions for analyzing your data. There are also geochemistry related packages, such as for development of aquatic chemical models, for thermodynamic models, or stable isotope geochemistry calculations. There are also water quality packages in R for exploring water quality, long-term water quality trends, for ecological assessment of surface waters, or clean water quality data. There are also marine biology related packages in R for example, marine benthic ecosystem analysis, for taxonomic information from World Register of Marine Species, for aquatic ecosystem modeling, such as for ocean biodiversity information system. For example, analysis of numerical plankton images. In R, there are also fisheries-related packages. For example, fish bioenergetics model, fish stock database, fishery science methods and models, and there are many packages for fisheries. There are also packages for paleontology, such as for categorical analysis of paleo-oceanographic data. You can view other packages under CRAN task views web pages. For example, they are categorized into several categories, such as ecological and environmental data, hydrology, spatial data, and spatiotemporal data. Now I want to continue with Python. Python is an interpreted, general purpose and object-oriented high-level programming language. It has some advantages as a data science tool. For example, it is a simple, readable, and easy to learn language. Python interpreter can run on multiple platforms. It is possible to express functions with fewer codes. It's an open source language, and it can be freely used and distributed. There are many libraries for scientific computing, and it is possible to use Python in combination with other languages. There are modules and packages in Python for a wide range of applications. A module is a file that contains functions and definitions. A package in Python is a collection of related modules in a single hierarchical structure. Some integrated development environments for Python are Python idle, the official IDE, Eclipse IDE, Eric IDE, Spider IDE, and Visual Studio Code. Python idle is an IDE component to build applications using the Python programming language. You write your code to editor and run the code and observe the results in the shell. Eclipse IDE have extended capabilities for modeling, charting, and reporting and testing. Using the marketplace in Eclipse, you can find, install, and vote for new plugins. You can extend the desktop by writing your own plugins. Eric IDE is somewhat similar, and Spider IDE is somewhat similar to others. You can install Python in Windows environment by going to python.org in download section. And Python comes pre-installed in Linux and Mac systems. In Mac systems, you can install individual Python packages from Python packaging index by using the below command or using package managers in these operating systems. Python can be installed by using scientific Python distributions. These distributions provide a great number of packages. You have the ability to create multiple self-contained environments. Each Python environment is independent from all of the others. As a result, users are able to work on multiple projects. You are able to test the programs against multiple versions of Python, and you can reproduce a codex environment for co-development, testing, or troubleshooting. For example, you can install a Python from for Python's website to your operating system, but this will be static. Instead, you can use Conda distribution, and you can have multiple programming languages in different environments, and you can install different versions of Python or R to different environments. It is also possible to use different versions of the programming language in different environments. You can use Python, R, Jupyter, TensorFlow, and Theano, and other programming languages in these environments. You can install Miniconda by going to the website. You can download the latest version for your operating system and your PC. For Linux and Mac systems, you can execute the installer, or for Windows, suitable installer. You can install the software with recommended settings. You can use Miniconda by going to Start menu and Anaconda you can click on Anaconda prompt. You can create a virtual environment by using the conda create script, and you can activate the new environment by using the conda activate environment script. There are many packages and repositories in the conda. However, most of the packages, for most of the packages, we need conda forge and free repositories. You can install these repositories by using these scripts. Then you can install the Python packages and other Python packages by using conda install or conda search scripts. This is the alternative Python distribution named Entat Deployment Manager. It's an alternative to conda environment. There are many packages in Python for data science. These packages are fundamental packages for handling scientific data. For example, NumPy, SciPy, Matplotlib, Pandas, scikit-learn, and stats models. For ocean science, there are many packages. For example, for time series data, you can use dateutil, utide, ttide, pytides, or pywavelets packages. In pytides, you can model your data and use already use data from the website of NOAA. There are also packages for acquisition of instrument data, for example, from ADCP instrument. You can view a 5-minute profile or other plots from the instrument. For example, a vector plot, you can draw a vector plot with CODAS. There are also packages for numerical modeling in oceanography. For example, you can use Octant for gridding, PyROMs, PyFVCOM, PyGridGAM for producing orthogonal grids. By using PyFVCOM, you can plot tidal components of surface currents. Also, you can view surface elevation, for example, in estuaries. You can use PyGridGAN for producing different grids in different areas, such as in an estuary. There are also generic mapping tools in Python, such as BaseMap, Cartopy, Folium. Folium is an interactive mapping tool. In BaseMap and Cartopy, there are many projections. You can select different projections for your project. Also, there are many hydrographic tools in Python, such as ArgoPy or CBSys. It is a Python module for calculating seawater, carbon, and boron chemistry. Also, there are many packages for handling CTD data or calculating seawater properties. You can use ArgoPy for Argo profiles, sampling of Argo profiles. You can view the coordinates of Argo. Also, by using CBSys model, you can view calculate and pH of the seawater. You can use Narwhal package for viewing temperature salinity diagrams or viewing as section plots. You can use data interface tools for taking the data in netcdf format, for example, or HDF5 format. There are many formats for storing oceanographic data in the web. You can reach to NOAA database and other databases, but you will take the data in netcdf format or HDF format. Therefore, these packages are useful. So what is netcdf data? It is a data file. That stores the data in the form of arrays. It can be a 1D, 2D, or 3-dimensional or 4-dimensional data. Therefore, we need special data formats to handle this kind of data. You can plot your, you can use different plotting tools in Python other than Matplotlib, such as Mayavi, ggplot, Bokeh, and MPLI D3. There are also common data model libraries in Python, such as Pyegon, Iris, and Python AirC for calculating the properties of AirC fluxes. And I want to continue with introduction to MATLAB. MATLAB name stands for Matrix Laboratory. MATLAB was written originally to provide easy access to matrix operations. MATLAB is a high-performance language for technical computing. It integrates computation, visualization, and programming environment. It has sophisticated data structures, contains built-in editing and debugging tools, and supports object-oriented programming. There are specific applications collected in packages referred to as toolbox, but you need a license to run MATLAB for personal use, commercial use, or teaching and academic research. It is possible to use it on desktop PC, online platforms, and mobile devices. You can easily interface MATLAB with other languages, for example, C, C++, C#, Python, Fortran, Java, and .NET. MATLAB environment is composed of several, you can use it for your several purposes. For example, you can write your own functions. You can use built-in functions. You can use toolboxes or Simulink for your project. You can view graphics. You can make computations, and you can access to external languages. There are many options for you can choose from. And there are many toolboxes and packages in MATLAB for oceanography. You can use, for example, time series tools, for example, UTIDE, glab, RWT, and timeplot for time series analysis. You can use SIGGRID for numerical modeling. For example, you can produce grids for ROMs and ECOM models. You can use mmap for mapping in MATLAB environment. You can use hydrographic tools such as GSW, a kriging module, EasyKrig, Dynemodes, and other packages for handling hydrographic data. There are also data interface tools, for example, handling different kinds of data files such as netcdf, OpenDep, HDF5 with NC toolbox, or there are also built-in netcdf and HDF5 libraries in MATLAB, in new MATLAB versions. Also, you can use AirC package for atmospheric and oceanographic time series measurements. There are also different other tools in MATLAB for oceanographic data processing. For example, for mooring design and dynamics, you can use mooring. For tidal data processing, you can tidal fitting toolbox. Also, tidal, you can use tidal ellipse toolbox. For ternary plots, such as for plotting sand, silt, and clay composition, you can use Shepherd ternary plot. For Argo deployments, you can use Argo toolbox. For accessing National Oceanographic and Atmospheric Administration website and its data, you can use MATLAB interface for NOAA data. You can use other toolboxes such as Phyton toolbox for statistical functions written to work with oceanography, fisheries, oceanography, and ecology data. And also there are toolboxes for converting oceanographic instrument files into netcdf files, or plotting these instrument files with imst toolbox and EasyPlot package. I want to thank you for listening me. This is the end of my presentation. Thank you for listening.
Thank you very much for your presentation on data processing tools. I think that it is very important training for the researchers who work at INOC member states countries. I would like to ask everybody, if they have any question, you can send your questions to the chat box. We can ask your question to the Dr. Hakan Alyuruk. Do you have any question? I think everything you mentioned in your presentation was understandable and everybody understood. Thank you very much, Hakan Alyuruk. We will share this webinar on our INOC website for researchers who couldn't attend this webinar. As INOC, we will continue to organize this kind of quality webinars to increase the capacity building of the institutions at INOC member state countries. I would like to indicate here that INOC President, Professor Dr. Sharmina Çınar, has made very serious contribution to the realization of these events. For that reason, I would like to thank for her continuous support and help. I think that we came the end of events. I would like to inform you once again that please don't forget to visit INOC website and social media tools to get more information about our international events. Finally, I need to say, before saying goodbye, I would like to share my screen. Dr. Alyuruk, could you please close your screen so that I can share my screen? Okay. I would like to show you your certificate. Thank you very much. On behalf of Inter-Islamic Network on Oceanography, I would like to thank you once again for your very informative presentation.
So I want to thank you. for giving me this opportunity to make this presentation today. Thank you very much.
You are welcome. Finally, I need to say goodbye to everybody. Looking forward to seeing you again in next INOC events. So, bye-bye.
Bye-bye.